Let me go ahead and record. Okay, so coterminal angles. Co is that prefix, right? Meaning together or with. So these are angles that they start in the same place, they rotate somehow and end in the same place, but the rotation is different in order to get to them. So that's coterminal angles, right? So visually, I want you to think about what's happening here. So think about the fact that we have this, we start in standard position, and if we rotate around to this particular place, so we've started in standard position, we're ending here in quadrant 3, and if you notice, they've labeled this angle alpha. I just realized I don't have my list of my Greek letters for you guys to help you understand the different letters that we're going to use to represent angle measures. So you've already seen theta, I know, but there's alpha and beta. There's a few that we're going to use pretty regularly, so I will make a list and get those up on the wall for you. So this angle alpha, that's a positive rotation, right? That looks like that's about, that looks like it's about 225 degrees, right? All right. We can also start in the same place and rotate this direction. We still stop in the same place. But to represent that angle, now that we're rotating in the negative direction, this angle beta, which is still these are coterminal angles, that looks like that would be about negative 135 degrees. So what we're saying then is that a 225 degree angle and negative 135 degree angle, they start in the same place, they stop in the same place, but obviously we're rotating differently in order to get to that place. Okay? So sometimes when you see coterminal angles, you're going to see that one's positive and one is negative. You can also have multiple positive coterminal angles. So that's what they're showing you in this other example here, right? We can start in our standard position and just rotate this 45, that's probably more like 60 degrees. So that would be angle alpha there, right? But to rotate differently and still end up in that same spot, this is saying we're going to start in the same spot. We're going to do one full rotation of 360 and then go this 60 degrees more. So that green rotation, that green angle, we've still started and we stopped in the exact same place. So these are coterminal. They're ending in the same place. They're together. Those are coterminal. So that is, yikes, cancel. I don't know how I managed to do that. Sorry about that. So this is 360 plus 60 degrees. So that gets us to 420 degrees. So a 60 degree angle and a 420 degree angle, those are coterminal also, right? So here's how we figure out coterminal angles. If you think about it, it just has to do with more rotations or a negative rotation. So we could add 360 or subtract 360 to come up with coterminal angles.
So you have CG for us?
I do, right here.
I have the one, so I just can see.
Yeah.
No worries. Okay. So if you think about it, it's basically a change or a rotation of either adding or subtracting 360 degrees, or if we're in radians, adding or subtracting what's equivalent to 360 degrees, which would be 2 pi, right? So in order to show or represent, if you notice it says, if alpha is the degree measure of an angle, then all angles measuring alpha plus or minus 360 degrees, however many times we want to do this, so times n. So times 1, times 2, times 3, times 4. So we can rotate 5 times around. We could rotate 2 times around. We could rotate in the negative direction. So anytime we are adding or subtracting 360 degrees, we're going to get a coterminal angle. Okay, so that's for in degree measures. Now notice though, if we're talking radians, sorry, I should highlight this too. If we're talking radians, then that means we're going to take our angle measure and we're going to add or subtract something equivalent to 2 pi. And then we're going to multiply by however many rotations we want to do. Okay? So let's look at some examples of this so that you kind of see or follow what this really means. And we're going to look at an example. If you notice, we're going to look at A, which is in degrees, and we're going to look at B, which is in radians. Okay? All right, so if we're dealing with an 80-degree angle, if you notice what the directions say, it says identify all angles that are coterminal with the given angle. So this part of it means we want to write, oops, let me fix that. We want to write this as 80 degrees plus or minus this 360 degrees times n, right? That's how we would represent any particular angle, right? I want you to visualize what an 80-degree angle is going to look like. It's going to start here at standard position, and we're going to rotate up to about right here, right? So that's an 80-degree angle. So in these other two places here, we are going to draw coterminal angles, but we're going to show different rotations for these. So we can, in order to show, it says, find and draw one positive and one negative angle coterminal with the given angle. So in other words, if we do 80 plus 360, we get that 440 degrees is a coterminal angle. So that means we're starting in standard position, we're rotating all the way around once, and then we're going to add 80 degrees more. So guys, if you think about it, it still looks like that original angle. It still is starting and stopping in the same place, but we've rotated differently to get there. Right? Similarly, if we want to come up with a negative angle, then we're just going to do 80 degrees minus 360. And so we get a negative 280 degrees. So that means we're starting here, standard position, and we're rotating in the negative direction to there. So guys, all three of those angles started and stopped, same exact place. But now there are three different angle measures there that we have that are coterminal with each other. 80 degrees, 440 degrees, negative 280 degrees. Okay, comments, thoughts, questions on that? Okay, let's talk radian measures. This one's a little bit different because we're going to have to come up with common denominator. So we'll deal with that here in just a second. So to identify any particular angle, then we would say negative pi over 4 plus or minus 2 pi times n, right? I want to do just a rough sketch over here off to the side of what negative pi over 4 is going to look like. So visually, negative pi over 4 means we're just moving, negative pi over 4 is equivalent to 45 degrees. So we're going negative 45 degrees, basically. So here's where my negative pi over 4 is. Let me darken these in. So we're going to draw two coterminal angles. We're going to show the different rotations here, okay? So for negative pi over 4, if I add 2 pi, only instead of 2 pi, I really want to add what's equivalent to 2 pi that has my common denominator. So if I multiply by 4, which is my common denominator, then I get 8 pi over 4. That's equivalent to 2 pi, right? So if I add that, so 8 pi over 4 and a negative 1 pi over 4, we get 7 pi over 4. So that means we're starting standard position. We are rotating around, and that angle looks about like that with the rotation. Okay, questions on that, especially the common denominator business? Okay. All right, the other way we can think about this, that was adding 2 pi, so now let's subtract 2 pi, or what's equivalent to 2 pi, and I'm going to just put the 8 pi over 4 here now, because you know where that came from. And we find that negative 9 pi over 4 is also equivalent to, is coterminal, excuse me. So negative 9 pi over 4 means we're rotating around this direction in the negative direction, one full rotation, and then that pi over 4 more to get to that place. Okay, so coterminal angles. Got to think about the fact that we're starting and stopping in the same place, right? All right, other questions or comments there? We're going to do a little bit of practice with that, and then we'll move on and we're going to talk about reciprocals. Okay, before we do that though, let's refresh our memory real quick. Angles in quadrant 1 are between what angle measures? 0 degrees and 90 degrees, good. You guys were worried about your quadrants, some of you right before class, so hopefully this is going to be a good reminder. Quadrant 2, the angle measures are between,
90 and 180.
yep, 90 and 180, thank you. Quadrant 3, what are the angle measures between?
180, 270.
180 and 270. Keep going, CJ, you're doing great.
270.
And then 270 and 360. Beautiful. And that's quadrant 4. So 1 starts top right, quadrant 2 is top left, quadrant 3 is bottom left, quadrant 4 is bottom right. Okay. Try these for yourself. If you notice, it's saying determine if the given angles are coterminal. So what my suggestion is, pick one of them and then add or subtract 360 to see if you get the other one. Okay, and then try the ones down at the bottom. If you notice, the directions here are saying find angle that's between 0 and 360. Okay. So, yeah, you may have to do some repeated addition. Add 360 multiple times in order to get to whatever you're looking for, that type of thing, right? Okay, onward. Guys, you are familiar with SOHCAHTOA, right? And we're going to talk about what those ratios mean. So remember, sine, that means the sine ratio is the opposite over the hypotenuse, or we abbreviate that. We kind of shorten that to O over H. We know cosine is adjacent over hypotenuse, so we shorten that to A over H. And tangent, we know, is opposite over adjacent, and so that's O over A, right? you need to learn and memorize the reciprocal trig functions for our sine and our cosine and our tangent, okay? And I'm gonna kind of explain a way to remember this. It kind of works for some people, others not so much. So you just gotta come up with what works best for you. So the reciprocal of sine is cosecant, and if you notice, it's shortened by writing it as CSC. So the reciprocal of sine is cosecant. The reciprocal of cosine, if you notice, is secant. And the reciprocal of tangent is cotangent. So let me say those again. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So the tangent and cotangent, that one's pretty straightforward and easy to remember. I'm not concerned about that one. But a suggestion in how you remember the sine, I thought I was in highlighter mode. The sine and the cosecant, and then the cosine and the secant, is if you remember cream and sugar. So within each pairing, you need a C and an S. Okay, so here we have the S, we have the sine. So the reciprocal function needs the C. So that's why it has to be the cosecant. Right? For this one, we have the cosine. So we have the cream, we have the C. We need the S. So that's why it has to be the secant. And then tangent and cotangent, those are reciprocals. So for some people, the cream and sugar helps them remember. Sine is and cosecant are reciprocals, cosine and secant are reciprocals, and so on. So the shortened way of writing those, the cosecant is written as CSC. Secant, the shortened version of that is the SEC, and then the COT for cotangent. Okay? So for what it's worth, I could not tell you what the ratio is for cosecant and secant and cotangent. What I can tell you is that I know that cosecant is the reciprocal of sine, and if sine is opposite over hypotenuse, then that means cosecant is going to have to be whatever that is flipped. So I think sine and then I flip it. So it's going to be hypotenuse over opposite. For secant, I don't have that memorized. I'm thinking reciprocal or flip of cosine. So it's going to have to be H over A. And for cotangent, I don't have that memorized, but I do know that it's flipping whatever the tangent is, so it's going to be A over O. So that's how I remember those. Personal preference, some people want to just memorize that. Your choice on how you kind of think through those. Okay? But yeah, you're going to have to start to get those memorized. All right, we're going to talk about some right triangle trig. But first, we're going to just refresh memory and review and reinforce what we already know. So the symbol that we use for sine is, the shortened way we write that is SIN. It is not sin, it is sine. And the ratio we know is opposite over hypotenuse. For cosine, we know we use COS. And we know that that is adjacent over hypotenuse. And for tangent, we are opposite over adjacent. Okay, so now these are the new ones that you need to know. These are our reciprocals. So for cosecant, the reciprocal of sine, we shorten that to CSC. So we can think of that as 1 over sine, or in other words, hypotenuse over opposite. Just flip it. For secant, we shorten that to SEC. And so it's 1 over cosine, or we flip it, so hypotenuse over adjacent. And for cotangent, yes, it's cotangent, not cot. So 1 over tan of theta, or adjacent over opposite. Okay. Okay, we need to talk about writing out the ratios and solving for using Pythagorean theorem, a couple of things like that. So if you notice, it says find the 6 trig ratios for angle A. So guys, this is angle A up here. So you kind of want to probably mark or label that in some way, shape, or form. And then it says, use the Pythagorean theorem to find the measure of side AC. Well, that's this side that can also be referred to as side B. So using Pythagorean theorem, we're looking for the hypotenuse. So that means we're doing 7 squared plus 10 squared equals B squared. So this side is equal to the square root of 149. If you can simplify the radical, you must simplify the radical. We will do some practice with doing that process. But yeah, it's going to be important that you're simplifying radicals if you can. Okay? All right. Now that we have all of the sides labeled, we can write our ratios. For some of these, we're going to have to rationalize the denominator. So I'm going to put work on the left-hand side of the question besides the right-hand side, just so we can fit this in here. So for the sine of angle A, sine we know is opposite over hypotenuse. So what's the ratio for that? Colby.
So opposite over hypotenuse. I put 7 squared is 149 over 149.
Okay, so yeah, it's 7 over the square root of 149. Good. So we have to rationalize that, right? So when we rationalize this, we're going to have to multiply by the square root of 149 over the square root of 149. So we get 7 root 149 over 149. Now, here's the beauty of reciprocals. To list the ratio for the cosecant, I want to look at this ratio and I just want to flip that. Because if I try to flip the final answer for my sine, then I've got another radical in there and that's messy. So for cosecant, it's just the square root of 149 over 7. Okay, what about the cosine of A? Yuhan, what do we get for that?
That is 10 over,
Yep, so 10 over the square root of 149. So for our cosine, for that answer, we do need to rationalize it. So we would get 10 root 149 over 149. But once again, for our secant, let's flip this. It's going to be easier, right? So square root of 149 all over 10. And then tangent. Talia, what's our tangent of A what's that ratio going to be?
7 over 10.
Good. 7 over 10. So our cotangent, let's just flip that. We get 10 over 7. Okay. Okay, onward. So sine, let's think reciprocals. Think cream and sugar. Sine of theta is equal to 1 over what? Leah. Sine of theta is equal to 1 over, what's the reciprocal function for sine? Think cream and sugar. Go back and look if you need to.
Is it the C one?
There you go. It is. It has to be a C, so it's the CSC, so cosecant of theta. There you go. Good. Because we need our cream and sugar. Exactly. All right, for letter B, secant of theta, and that's equal to 1 over what trig function? Owen? We have our S, our secant, so we need our C. So for secant, flip back a page or two. Where is that? I don't remember. Cosine, there you go. So secant of theta is equal to 1 over the cosine of theta. Cotangent of theta is equal to 1 over what? Dina?
Tan.
Yep, 1 over tangent of theta. Good. Letter D, cosecant of theta is equal to 1 over what? Sophia? Sine theta. Good. We have our C with the cream, and then we need our S, so sine. And then for letter E, we have our C, that's our cream, that's cosine. So we need our sugar, we need S. So cosine of theta is 1 over what, Talia? Careful. It does start with S, but it's not the sine. Secant. There you go. Good. So cosine of theta is 1 over secant theta. And then tangent of theta is 1 over, Elena? Cotangent of theta. There you go. Okay. I'm trying to decide, we probably should review a little bit here with Pythagorean theorem, but I don't want to. We're going to do it in context. So we're going to skip over to, actually, no, I lied. Let's take a look at letter C at least. Please be very careful with this because the tendency is to see 15 and 17 and think, oh, the other side must be 8. What's wrong with that? Yeah, the 8 can't be the hypotenuse. 8 has to be a leg, and then 15 has to be a leg. 17 has to be the hypotenuse. So on this one, you definitely, it looks like it should be a triple, but it's not. So actually you get that C squared is 514. So C is the square root of 514, which in this case, as a decimal, is 22.672. So we're going to look at some examples with Pythagorean theorem here on the next page in context. But that is a quick reminder to just be careful and don't get caught by having memorized those triples because you can get caught and accidentally make a mistake there. Okay. If you are given right triangle here, we are missing a side before we can state some ratios. So which one of those do we want to do on top? Let's do the top one. We're not going to do both of them. We are looking at things from this perspective, from angle A. We need to do Pythagorean theorem in order to figure out what the length of B is, or hypotenuse in this case. So we're going to do 8 squared plus 12 squared equals B squared. You get that B squared is equal to 208. When you take the square root of that, you do have to rewrite and simplify the radical. So it ends up being 4 times the square root of 13. All right, so for the sine of angle A, what's that ratio going to be? Someone help me with that. John, what's the sine of A going to be?
So it's opposite over hypotenuse, right?
Yep.
I forget which one. How do you tell what's the hypotenuse one?
Hypotenuse, remember, is always, in fact, my suggestion, whenever you see that right angle, if you have a hard time picking out the hypotenuse, just highlight it or mark it somehow. So remember, the hypotenuse is always the side opposite the right angle.
Okay, so is it 12 over 4? Is it
So for sine of this angle, sine we want to go opposite, which means across.
Okay, so it's
8 over, and then hypotenuse, which is this 4 root 13. Right? There you go. Okay, this can simplify. So this is 2 over root 13, and then we've got to rationalize. So there's quite a few steps on this one, isn't there? But for cosecant of A, that one's pretty easy because we're gonna flip this. So square root of 13 over 2. All right, what about the cosine of A? Who's got that one? CJ, can you help me with that one?
Yeah, it's the adjacent over the hypotenuse.
Adjacent over hypotenuse, so what's that gonna be?
12 over 4 root 13.
Okay, 12 over 4 root 13. That simplifies also. And so we get 3 root 13 over 13. Let's flip this. So root 13 over 3. And then what about our tangent? Sam, what's our tangent value going to be?
Tangent is opposite over adjacent, so 8 over 12.
Good. Which simplifies. So 2 over 3. So our cotangent is going to be 3 over 2. Right? Okay. All right. Hang in there. We're getting close. This last little bit here and then a little bit on the next page. I just want to refresh your memory. Somebody earlier was talking about that 45, 45, 90, 1 squared of 3, 2, and 30, 60, 90, and all of that business. They are related there, right? So if we see that this is a 45-degree angle, we know this is also 45 degrees, and we know we're dealing with that for our lengths of our sides, right? If we are told that BC is equal to 3, that means the length of this side is 3. Then that means this whole triple is just getting multiplied by 3. So that means this leg is 3, and this hypotenuse is 3 root 2. So AC is also equivalent to side B, and that would be equal to 3. And AB is our hypotenuse. That's equivalent to side C, and that's 3 root 2. And then this is a 1 square root of 3, 2. AB, which is also side C, that is 14. If that's 60, then we know this is 30. So we have to think about how these lengths, what the ratio is here, what we're multiplying by. So the hypotenuse is 14. That means we're multiplying everything by 7, right? 2 times 7 gives us 14. So if we multiply by 7 here and multiply by 7 here, so that means the side opposite the 30-degree angle has to be 7. The side opposite the 60-degree angle is 7 root 3. And I went through that pretty quickly, so I need you to kind of go back and look through those. Let me know. I've got one other thing I'm going to show you to help you get started on your homework. And then if you need me to kind of talk you through that again, I will be glad to do that. Okay? If you notice on the board, your homework is page 17. And I want to show you just one quick example. I think for the top, I think you should be okay, hopefully. Think about your reciprocals and write out your SOHCAHTOA if you need to. But I do want to show you an example down here. So let's look at number 5. You're given a ratio. So you're going to have to draw triangles. It doesn't matter where you choose to put the angle. your choice, right? But we're told that the tangent ratio for tangent of theta is, we know tangent is opposite over adjacent, and we know it has to be 3/4. So then we're gonna have to figure out what that other side is. The nice thing is that that's a triple, and you know it's a triple, so it makes the work pretty easy there. And now we're supposed to figure out what the cosecant is, what the ratio is for the cosecant. Cosecant's the reciprocal of what? What ratio do you know that's reciprocal of? Sine. So let's figure out what the sine of theta is, and then we're just going to flip it. Right? So sine, we know, is opposite over hypotenuse. So sine would be 3/5, so that means our cosecant is going to be 5/3. Okay? So for all of these down here, you are going to want to draw a picture, draw a triangle. You're going to have to label and come up with another side. And then you're going to have to think reciprocals in most instances in order to come up with the ratio that you have to do. Okay?